So now that we know about the subatomic particles that make up our atoms, we're going to talk about something called isotopes. Our original assumption from the end of last semester was that if you have a certain element, all of the atoms of that same element are going to be identical. So if you have a group of lithium atoms, all atoms of lithium will be identical. That's what we assumed. In reality, each of these numbers can change. If we change the number of electrons, we make a positive or a negatively charged particle, or an atom, called an ion. And we're going to talk about ions more later. But we can change the number of electrons. Remember, that changes whether something's positively or negatively charged. And we call those charged particles ions. If we change the number of neutrons, we create atoms that have different masses. So we're changing the mass of that nucleus. And we call those atoms that have different masses isotopes. They're still the same atom, but they have slightly different masses because they have different numbers of neutrons. And those are called isotopes. The number of protons will never change if you want to keep it as the same element. Once you start changing the number of protons, you change the identity of the element. If you change something from having 1 proton to 2 protons, you've changed it from an atom of hydrogen to an atom of helium. So they're 2 completely different atoms. You can vary the numbers of electrons and neutrons and still have the same element. Different parts of it will change, but it'll still be the same element. Once you change the number of protons, you've changed what that element is. So let's look at where we get all of this information, because we can find it all from our periodic table. So when you look at the box on a periodic table, the first thing you notice, and it's what we focused on so far, is the symbol and the name. So we're going to keep going with lithium as our example. So in the box, you'd probably see the symbol and then the name underneath of it. And then there's a number at the top. And in the periodic table, that number goes sequentially. So it goes 1, 2, 3, 4, and then across your periodic table. We'll talk more about trends here in a couple of days. But that number at that top, that whole number, that's called the atomic number. And then the number down here is the number we've been using so far, and that's the average atomic mass. So it's the average masses of all of the different atoms. If we want to actually be able to calculate the mass, we need to know the exact mass of that particular atom. So we use something called nuclear symbols, and that tells us exactly what's going on in the nucleus. And there are 2 ways that you can write nuclear symbols. You'll see them like this, where you have the symbol and you have 2 numbers. So the symbol is still lithium. In this case, the atomic number is in the bottom left-hand corner. And this number up here is the mass number. Notice this number is a decimal, it's an average. This number down here, the 7, that's a whole number. You can't have a decimal for a mass of a single atom because you can't have part or a fraction of a proton or a neutron. You're going to have a whole number for your mass number. You could also see it written the symbol and then a dash, and then you'll see the mass number. In this case, notice the mass numbers are the same, but there's no atomic number. Well, we can use the periodic table to find the atomic number because we can look on our periodic table, find lithium, and know that the number at the top is our atomic number. So what do these numbers actually tell us? So if we want to determine the parts of an atom, we need to use all of these numbers together to determine how many protons, neutrons, and electrons we have. So we're going to keep going with lithium. To determine the number of protons, you're going to look at the atomic number. So lithium has 3 protons because its atomic number is 3. If I wanted to know how many protons helium has, I look on my periodic table. The atomic number of helium is 2. So that's going to be different for each of the different elements. So lithium has 3 protons. Now if I want to figure out how many electrons I have, that is also the atomic number. Remember, our protons are positively charged. If our atom is going to be neutral, so if it's neutral, we're going to have the same number of positives and negatives. So we're going to have the same number of protons and electrons. For right now, we are going to assume all atoms are neutral. We'll deal with changing charges later. Now, if we want to figure out how many neutrons we have, it's the mass number minus the atomic number, because our protons and our neutrons make up our mass. So if our mass is 7, and 3 of that 7 are protons, if I subtract that, that leaves me with 4 neutrons. If you add your protons and your neutrons together, you should get the mass number for that atom. So 4 plus 3 gets me 7. Let's work through a couple more examples. So my first one, hydrogen 1, 1. So the bottom number is the number of protons. That also tells us if this is neutral, that we have 1 electron. We're going to have equal numbers of protons and electrons. My mass number is 1, so if I do mass number minus my number of protons, I end up with 0. Hydrogen with 1 proton has no neutrons. It's just 1 proton and 1 electron. Here's a different form of hydrogen. This is a different isotope of hydrogen, where it's still hydrogen, we still have 1 proton, and we have 1 electron, but in this case our mass number is 2. So we'll do 2 minus our number of protons, so 2 minus 1 gets us 1. So this atom of hydrogen would have 1 proton, 1 neutron in its nucleus, and then 1 electron. Let's move on to a slightly more complicated one. Let's look at bromine. So bromine has an atomic number of 35, so that tells us that we have 35 protons. If it's going to be neutral, we're also going to have 35 electrons. Now, to figure out how many neutrons this atom of bromine has, we take the mass number minus the atomic number, and that'll give us our number of neutrons, which is 45. If I add these two numbers together, I should get my mass number. Okay, next example. We're going to switch up how these are written here just for a second. So RH is rhodium. That's not one that we had to memorize, but you can find it on the periodic table. And it's rhodium 103. So if I look on my periodic table, RH is right there. If I look in the box, it's 45. That's its atomic number. So that's how many protons I have. If it's neutral, I'm also going to have 45 electrons. So now I have to figure out how many neutrons I have. So I'm going to do my mass number, 103, minus my number of protons, 45, and that gets me 58 neutrons. So this atom of rhodium has 45 protons, 58 neutrons, and then 45 electrons. Last example, we're going to look at vanadium. So if we find vanadium on our periodic table, it's right here, it's V. It has an atomic number of 23. So that's how many protons I have. If it's neutral, it's also going to have 23 electrons. Vanadium 51 tells me that it has a mass number of 51. So if I do its mass number minus its number of protons, 51 minus 23 gets me 28 neutrons. So I have 23 protons and 28 neutrons in its nucleus, and it has 23 electrons floating around the outside.